after the radius and velocity of electron in the nth orbit, okay, we need to find kinetic energy, comma, potential energy, and total energy. With respect to this total energy, we are having the hydrogen spectrum. We are having the hydrogen spectrum. So kinetic energy we can write as half mv square, where m is the mass of electron and v is the velocity of the electron in the nth orbit. That is, we are going to find the kinetic energy of an electron in nth orbit. In nth orbit. That is, substitute the value of velocity of electron. That is ze square by 2nh epsilon naught whole square. That is mz square e power 4 by 8 n square h square epsilon naught square. So kinetic energy is equal to mz square e power 4 by 8 n square h square epsilon naught square, called as equation 1. Okay, that is the equation for the kinetic energy. Okay, keep it in box. Okay, next I want to find the potential energy. Since potential energy U is equal to integral F times dr. Okay, that is, in the Bohr's atomic model, okay, we are having a nucleus having a charge Zt, and we are considering an electron which is revolving around the nucleus in the nth orbit. In the nth orbit. Okay, so here we are having the force means Coulombic force, that is 1 by 4 pi epsilon naught ze square by r square. Okay, or preferably we can write as Rn, radius of the nth of electron in the nth orbit, r square into dr. That is, with respect to r, I am integrating it. So ze square by 4 pi epsilon naught integral 1 by r square dr. That is minus ze square by 4 pi epsilon naught into 1 by r. Integral 1 by r square dr means minus 1 by r. Okay, right? Okay, fine. So minus ze square by 4 pi epsilon naught 1 by, we know the value of r, that is radius of electron in the nth orbit, that is this value, h square epsilon naught or n square h square epsilon naught by pi m ze square. So we'll get it as ze square will, so minus pi m z square e power 4 by 4 pi epsilon naught into n square h square epsilon naught square. Okay. Four pi epsilon naught into n square h square epsilon naught. Okay, n square h square epsilon naught. Okay, fine. So pi will get cancelled. Any other term? So potential energy U is equal to minus mz square e power 4 mz square e power 4 divided by 4n square h square epsilon naught square. That is the potential energy. Okay. Already we got that kinetic energy. Okay, already we got the kinetic energy. That is mz square e power 4 mz square e power 4 divided by 8 n square h square epsilon naught square. 8 n square h square epsilon naught square. Okay, so total energy means sum of the kinetic energy plus potential energy. Find out the value of total energy. That is mz square e power 4 divided by 8 n square h square epsilon naught square potential energy minus mz square e power 4 by 4 n square h square epsilon naught square. Mz square e power 4 by 4 n square h square epsilon naught square. Take common 1 by 2 minus 1. So total energy E is equal to 1 by 2 minus 1. I can write as minus 1 by 2 minus mz square e power 4 divided by 8 n square h square epsilon naught square. Can I write? From the, suppose this one it is equation 4. From equation 2, 3 and 4, okay, I can write it as the total energy is equal to minus kinetic energy, okay, and the total energy is equal to potential energy by 2. Can I write? Hello? Hello?
Yes, sir. Yes, sir.
Raja? Okay, okay. That is the expressions for kinetic energy, potential energy, and total energy. Okay, okay. Keep the side heading, this one, and write down. Okay, completed. Completed this page. ఉమర్, మరి నీ దగ్గర ఇది నారాయణ మెటీరియల్ ఉందా ఫస్ట్ ఇయర్ది? ఉందా? షణ్ముఖ్ నీ దగ్గర ఉందా నాన్న? నారాయణ మెటీరియల్ ఉందా ఫస్ట్ ఇయర్ది?
ఉన్నట్టున్నాయి.
ఒకసారి చూడు, లేదంటే సాఫ్ట్ కాపీ పెడతాను.
ఓకే సార్.
నువ్వు పొద్దున్న 6 o'clockకి రాగలవా క్లాస్కి? ఆన్లైన్లో, ఆన్లైన్, నాట్ ఇన్ ఆఫ్లైన్.
ఏ చాప్టర్కి సార్?
ఫ్లూయిడ్స్, తర్వాత ఆసిలేషన్స్, అండ్ దెన్ మధ్యాహ్నమేమో సెంటర్ ఆఫ్ ఇప్పుడు వర్క్ పవర్ ఎనర్జీ నడుస్తుంది. వర్క్ పవర్ ఎనర్జీ, సెంటర్ ఆఫ్ మాస్, కొల్యూషన్, రొటేషనల్. ఒక 15 to 20 days. భార్గవి, మనసానికి మేడం పొద్దున్నే 7ంటికి లేస్తున్నారా 6:30కా?
నేను 5:30కి లెగుస్తున్నా సార్.
అయితే 6 కన్నా రాగలరు.
ఎన్నింటికి సార్ క్లాస్?
6 o'clock, 6 AM.
6
అవును.
6 to 7
7:30. మళ్ళీ నెక్స్ట్ ఫాలోడ్ బై మీది.
సార్ మరి అయితే మీరు 8 కన్నా తీసుకోండి సార్.
ఏందమ్మా?
అంటే ఆ క్లాస్ 6 to 7:30 ఉంది కదా, మీరు 8 కన్నా తీసుకోండి.
ఎందుకు?
ఒక హాఫ్ అన్ అవర్ అన్న మధ్యలో బ్రేక్ కావాలి కదా సార్.
హాఫ్ అన్ అవర్ బ్రేక్ కావాలా?
అంటే ఫ్రెష్ అవ్వడానికి. మళ్ళీ మాకు 11 వరకు క్లాసెస్ కంటిన్యూస్ గా ఉంటాయి, 10:30 ఆల్మోస్ట్.
అమ్మా, మీకు ఒక విషయం చెప్పనా?
చెప్పండి.
నేను పెద్దమ్మ టెంపుల్ జూబ్లీ హిల్స్ నుంచి అక్కడి నుంచి వచ్చి ఇక్కడ పాఠం చెప్తాను. 4 o'clock లేచి రెడీ అయ్యి అంతా చేసుకుని కార్యక్రమాలు అంతా చేసి 5:30, 5:40 కల్లా సర్దార్ పటేల్ నగర్లో ఉంటుంది. 5:40 కల్లా ఉంటుంది. ముందరే ఒక 10-15 minutes ముందరే ఉంటుంది. తప్పదు. ఈ 3-4 నెలలు, ఇంకొక 4 months సీరియస్ డెసిషన్స్ అవి లేకపోతే మనకు వర్కౌట్ అవ్వాలి.
ఓకే సార్.
గాయత్రి, శ్రీహిత, గాయత్రి అమ్మ, మాస్టర్ జీ గాయత్రి, ఎస్ గాయత్రి. శ్రీహిత, లేదా? సరే, ఈ పేజ్ అయిపోయిందా? కంప్లీటెడ్. దిస్ పేజ్ కంప్లీటెడ్. ఉమర్ లేటెస్ట్ న్యూస్ తెలుసా? జేఈ మెయిన్స్
తెలుసు సార్, 4 టైమ్స్ పెడతా అంటున్నారు.
ఎవ్రీ మంత్ ఉంటుంది.
ఫిబ్రవరి నుంచి మే దాకా 4 టైమ్స్ పెడతారండి.
అదే
మొత్తం విన్నా సార్, లైవ్ మొత్తం. లైవ్ లోనే ఉన్నా నిన్న మొత్తం.
అదే అందుకని completed. Hello, completed. Okay, all of you completed. Okay, fine. See, this kinetic energy, it is the energy obtained by the electron in revolving around the nucleus. Okay, in revolving around the nucleus. And this potential energy is required by the electron to interact with the nucleus. During the interaction, either the electron may goes to higher excited state, or it may goes to the next lowest energy state. So E is the total energy. E is the total energy required. Total energy required to move an electron. To move an electron from lower state to next higher state. Next higher state. Okay. So here we are having that ionization energy. The energy required to remove an electron. The energy required to remove an electron can be called as ionization energy. That is given as E is equal to minus m z square e power 4. Z square e power 4 by 8 n square h square epsilon naught square. This I will write it as minus m e power 4 by 8 h square epsilon naught square times z square by n square. First, I will find the value of m e power 4 by 8 h square epsilon naught square. What is the mass of electron? Mass of electron 9.1 into 10 power minus 31. Charge of electron 1.6 into 10 power 10 power minus 19 whole power 4 by 8 into Planck constant 6.63 into 10 power minus 34 whole square. Epsilon naught square, that is 8.85 into 10 power minus 12 whole square. Find out the value. 9.1 into 1.6 whole square means it is 2.56. So 2.56 whole square, 6.5536. 10 power minus 31 into 10 power minus 38 and 76 divided by 6.63 square. that is 1443.9569 into 8.85 square, 78.3225, 10 power minus 68 into 10 power minus 24. So numerator it is 9.1 into 6.5536, 59.63, 59.63776 into 76 plus 31 అంటే 107, 10 power minus 107 divided by 8 into 43.9569 multiplied by 78.3225. That is 27542.5144. 68 plus 24, 92. 59.63776 divided by 27542.5144. That is 0.002165 into how much will get 10 power minus 15, then idemo 8 to 7, 10 power minus 15. So identity joules, convert into electron volt, 0.002165 into 10 power minus 15 by 1.6 into 10 power minus 19 electron volt. So 1, 2, 3, 4. So 21.65 by 1.6 EV. That is 21.65 divided by 1.6. 13.531 EV. Approximately, we'll write it as 13.6 electron volt. So that's why this value it is 13.6. So we will write it as energy of an electron in the nth orbit it is minus 13.6 z square by n square. ఇక్కడ చూసినట్టుగా ఉందా ఫార్ములా 13.6 z square by n square. Okay. I think up to here you wrote. Write down. Keep the side heading as ionization energy. Keep the side heading. సార్ ఉన్నా సార్. సార్ సార్ ఓకే 8 అని కాదు సార్. ఓకే సార్. ఓకే రైట్ డౌన్. Completed this page?
Yes, sir.
పెట్టండి. మేడం లింక్ పెట్టే మేడం చూడండి ఒకసారి. 4978 నెంబర్ కంప్లీటెడ్. హలో, అయిపోయిందమ్మా? Suppose, let us consider I am having an electron in the first orbit or ground state. N equal to 1 means ground state. Okay. So energy, okay, I am considering for hydrogen atom. I am considering for hydrogen atom. Okay. E1 is equal to minus 13.6 Z square by N square. For hydrogen atom means Z equal to 1 and N is equal to 1. So E1 ground state will be 13.6 electron volt is required to ionize the electron. For the same hydrogen atom, if the electron in the second orbit, I can write it as minus 13.6 into 1 whole square by 2 square. That is minus 13.6 by 4. That is 3.4 eV. 3.4 eV. So change in the energy, that is delta E, is equal to E2 minus E1, that is minus 3.4 minus of minus 13.6. That is 13.6 minus 3.4. Okay, that is 10.2 electron volt. Okay, like this we'll find the energy difference. Energy difference, that is delta E equal to, okay, E2 minus E1. Let us consider E1 is equal to minus 13.6 Z square by N1 square, and E2 will be minus 13.6 Z square by N2 square, right? Can I write? That is E2 minus E1 is equal to minus 13.6 Z square by N square plus 13.6 Z square by N1 square. Antena? Is it right? So E2 minus E1 is equal to 13.6 Z square times 1 by N1 square minus 1 by N2 square. See, 13.6 means here we got the value, that is this one, m e power 4 by 8 h square epsilon naught square. That is m e power 4 into z square by 8 h square epsilon naught square. H square epsilon naught square times 1 by n1 square minus 1 by n2 square. 1 by n1 square minus 1 by n2 square. Okay. Okay. This is the change in energy. Change in energy. Now, here we know that energy is equal to hc by lambda. Right? Hello? Antena?
Yes, sir.
So, hc, that is delta E equal to change in energy hc by lambda. That is m e power 4 z square by 8 h square epsilon naught square into 1 by n1 square minus 1 by n2 square. That is 1 by lambda equal to m z square e power 4 by, bring this hc to the down, 8 h cube c epsilon naught square 1 by n1 square minus 1 by n2 square. So except z square, remaining all the terms are constants only. So I can write as rz square times 1 by n1 square minus 1 by n2 square, where r can be called as Rydberg constant. Rydberg constant. We need to find this value. That is r is equal to m e power 4 by 8 h cube c epsilon naught square. Epsilon naught square. Okay. See. So here I can write as 1 by hc into m e power 4 by 8 h square epsilon naught square. So that is this value, we know that it is 13.6 electron volt. Okay, Hc, that is 6.63 into 10 power minus 34 into 3 into 10 power 8. This is in joule second. It is in meter per second. Denominator is in SI unit. So convert this numerator into SI unit. That is 13.6 into 1.6 into 10 power minus 19. Denominator it is 6.63 into 3. That is approximately 19.89 into 10 power minus 26. So calculate this value. Calculate this value. 13.6 into 1.6, that is 21.76 by 19.89 into 10 power 7, that is 21.76 divided by 19.89, 1.094 into 10 power 7. Okay, meter inverse. Okay, that is the value of Rydberg constant. I think up to here you wrote, na? ఇక్కడ వరకు రాసుకున్నారమ్మా?
Yes, sir.
Okay, after that write on this one. En is equal to minus 13.6 z square by n square. Okay, na?
Completed, sir.
Okay, next this one. Okay, na? Or okay, completed.
Yes, sir.
Okay, completed.
Yes, sir.
Remember this formula. Okay, over. Completed.
Yes, sir.
Okay. Next, see, 1 by lambda equal to r z square times 1 by n1 square minus 1 by n2 square. That is, electron is emitted from second to first orbit, or third to first, or fourth to one, like this. Or electron may emits from third orbit to second, fourth orbit to second, okay, like this. So depends on that. Here for hydrogen atom, we are having an spectral lines or spectral series for hydrogen atom. Okay, okay. We are having the 5 spectral lines are there. One is Lyman, next Balmer. Okay, second is Balmer, and third it is Passion. Fourth it is Bracket, and fifth one it is Fund. That is, Lyman series means N2 will be 2, 3, 4, and so on infinity to N1 equal to 1. Balmer N2 equal to 3, 4, 5, and so on infinity to N1 is equal to 2. Passion 4, 5, 6, and so on infinity to N1 is equal to 3. Bracket 5, 6, 7, and so on infinity to N1 is equal to 4. Fund, that is 6, 7, 8, and so on infinity to N1 equal to 5. N1 is equal to 5. Okay, these are the we are having. For each series, we'll have a longest wavelength and shortest wavelength. Okay, since delta E is equal to hc by lambda, as energy is maximum, wavelength will be minimum. Okay, and vice versa. Okay, as energy is maximum, we'll have the minimum. First, I'll find for Lyman series, I'll find the shortest wavelength. Shortest wavelength in Lyman series. Okay. Okay, fine. Suppose this is N1, that is 1. N2 equal to 2. Okay, from here to here. Okay, and 3. This is 3. Okay, suppose this is 5. And so on to, suppose it is infinity. This energy, you can see, it is less. So we'll call it as the longest wavelength. Sorry. 1 by lambda. Okay. This one it is shortest wavelength. Shortest wavelength. And this one it is longest wavelength. Always the longest means, okay, 1 plus the ground state. Okay. Shortest wavelength means in Lyman series means N1 equal to 1 and N2 equal to infinity. So 1 by lambda equal to, since it is a hydrogen atom, Z equal to 1. 1 by 1 square minus 1 by infinity square. So 1 by lambda equal to R. Lambda equal to 1 by R meters. Okay. 1 by R, it is having a value 1.094 into 10 power 7. Right? Find out the value of this one, 1 by R. That is 1.094 inverse. 0.914076 into 10 power minus 7 meters. Multiply and divide by 1000. So that we'll get 914.076 angstrom units. 1 by R value is, remember this value. Many times we'll get. Okay. So shortest wavelength in the Lyman series it is 1 by lambda equal to R. Similarly, longest wavelength in the Lyman series. In the Lyman series, that is 1 by lambda equal to R into 1 by N1 square minus 1 by N2 square. In the Lyman series, N1 is equal to 1 and N2 equal to 2. So it is R times 1 minus 1 by 4. That is 3R by 4, 1 by lambda, or else I'll keep as lambda L. So lambda L equal to 4 by 3R. 4 by 3R. So that is 4 by 3 into 1 by R already we got 914.076 into 10 power minus 10 meters. That is angstrom. Okay. So 4 into 914.076 that is 3656.304 by 3. 1218. Longest wavelength it is 1218 angstrom meters. Whereas shortest wavelength it is 914. Lambda S in the Lyman series it is 914 angstroms. Longest wavelength it is 12. Similarly, Balmer series. In Balmer series, what will be value of N1? N1 is equal to 2, N2 equal to 3, 4, 5, and so on infinity. For shortest wavelength, what are the values of N1 and N2? Shortest wavelength. N1 is equal to 2, N2 equal to infinity. 1 by lambda S equal to R into 1 whole square. 1 by 2 square minus 1 by infinity square. 1 by lambda S equal to R by 4. So lambda S is equal to 4 by R. 4 by R. Similarly, longest wavelength. Longest wavelength. That is N1 is equal to 2, N2 is equal to 3. So 1 by lambda L is equal to R into 1 whole square. 1 by 2 square minus 1 by 3 square. Hello? నీకు పెట్టాను చూడండి నేను అది కదట ఇందాకే పెట్టాను ఇందాకే పెట్టా కదా ఓకే 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 పెట్టేసి okay in the Balmer series shortest wavelength and longest wavelength okay fine. I think up to here you wrote అవునా ఇక్కడ వరకు రాసుకున్నారు కదా
Yes, sir.
రైట్ okay completed
Yes.
Okay. Here I calculated shortest wavelength and longest wavelength in Lyman series and Balmer series.